Hello friends and welcome to another lecture on chemical engineering thermodynamics. Today we look into a problem which has come in Mumbai University Chemical Engineering Thermodynamics 2 paper on May 18. The question is 3A and it is on your screen. What we have is we have two equations for the activity coefficient, that is gamma 1 and gamma 2. That is gamma 1 is the activity coefficient of component 1 and gamma 2 is the activity coefficient of component 2. Now what is asked is, does it satisfy Gibbs Duhem equation and determine the excess Gibbs free energy? So the Gibbs Duhem equation for a binary system is x1 ln d ln gamma 1 by dx1 plus x2 d ln gamma 2 over dx2 is equal to 0. Now we should note that for a binary system x1 plus x2 is equal to 0 and dx1 is equal to minus dx2. Well, that's natural. If you differentiate it, you will get this. Now differentiating d, that is ln gamma 1 with x1, we get the following, that is 2a x2 dx2 by dx1. That is because what do we have here is that if we differentiate this, we get 2a dx2 by dx1. That is what I have written here. And then the other part of this equation, that is bx2 the whole square 3x1 minus x2. We use the product rule to differentiate it and we get the same results. That is, wherever we differentiate it with x2, we write it as dx2 by dx1. Now, remembering that dx2 by dx1 is minus 1, we replace that and we simplify and get this equation. So we have got equation number 2. Now we do this similar for ln gamma 2. So here it goes. We have only one dx2 by dx1 here and we replace this with minus 1 and we get the following equation, that is 3. Now multiply it with, that is equation 2 with x1 and equation 3 with x2 and add it. So let's go here. So it's just like replacing d ln gamma 1 by dx1 and d ln gamma 2 over dx2 in the Gibbs Duhem equation. It's the same and we get this expression and this obeys Gibbs Duhem rule. The reason here is plain simple here. We have this equation, right? So 2a x1 x2 minus 2a x1 x2, these two will cancel and it's 0, and you have 6b x1 x2 x2 minus x1 and you have 6b x1 x2 x1 minus x2. So these two will also cancel off and we get 0 here. Therefore the system obeys Gibbs Duhem rule. Now the excess Gibbs free energy is given by this equation, that is GE by RT is summation of I, where I is all the components, xi, which is the mole fraction of component I, into ln gamma I, that is the log natural of the activity coefficient of the component. So we write this out, GE by RT, okay, x1 ln gamma 1, x2 ln gamma 2, and we simplify this equation. We get this equation after multiplying x1 with ln gamma 1 and x2 with ln gamma 2 and adding it up. So this is the final expression we obtain for GE over RT. So that was all, guys. This was for 12 marks and it was a fairly simple problem which took a little bit of calculus to solve. I do agree that yes, a very basic amount of calculus is required. Differentiation with care is required to solve it. But be sure that you learn this method and practice solving this particular problem. at least 4 to 5 times before you go for the examination, because this is a very fairly common problem asked in CET 2 question papers, and it's a fairly common problem asked in GATE 2. So please remember one thing, that if you have a good idea about how to solve it, you can even clear questions that have been put up in GATE, that is the entrance test for masters. So fine guys, hope you have enjoyed this lecture. Please do subscribe my channel, and please do forward my videos to students and ask them to subscribe my channel. My current subscription is 612. I need to touch 1000 subscribers before this project becomes viable. I am very interested in this project. This project is very close to my heart. That is bringing thermodynamics very clearly in a very easy fashion to all the students and professionals. I am Professor Arvind Prasad. I have been teaching thermodynamics for almost 2 decades now. So goodbye friends. Have a great day. Like my channel and subscribe it.